Good morning, physics fans. This is Mr. Russo with some just-in-time education. So, watching many of you struggle yesterday with Excel, I figured I'd do a tutorial so that when you got caught procrastinating, you could self-rescue. Here we go. So, you'll notice that I'm on the tab for the Energy Lab called Drop Object, and it's awful. Oh, there's the wife. Anyway, there you can see that it's kind of blank. So this is an assessment. I'm looking to see if you can do these skills, and I'm finding that it's no. So I've got a whole string of gate times. I have the length of the object. I need to know the velocity of this object. So I'm going to go length or distance, right? Because that is the distance that the motion sensor sees. And then I'm going to label a column velocity. And that's going to be in meters per second because I'm going to work always in my base units because that's a thing that I've been saying to you since when? I don't know, the beginning of the school year. All right, here we go. Distance. The distance that it sees is whatever I drop through the photo gate. So that's 0.04204. I'm just copying from above. Then I grab and I drag all the way down for my data set. Boom. I go up to my velocity column and I go, Excel, do math for me. I press the equal sign. I go, first week of physics, velocity is distance, right? Whatever's in cell B6 divided by time. Oh, it looks so easy when I do it. Right? And then I go, yeah, I want you to do that all for me because I don't really want to pick up my calculator. Oh, there's why I love spreadsheets. Okay. There we go. And then I go, well, he's always told me that I need to do an average and I should leave space and do a standard deviation because I'm interested in what my data set looks like. And so for average, I come over here. Oh, let's make it a nice color, right? Let's make average blue. Oh, your tools look different when you're in this. Well, I'm not going to get fancy. Average. So again, do math equals A, V. Oh, look at that. There's all kinds of averages. We just want average, the regular one. And it says, what do you want me to do an average of? Well, I'm just going to grab and drag that whole column of velocities, right? Because what's the central tendency? Boom, enter. I go, I better check my, oh yeah, this is, the tools are definitely different when you're in Screencast-O-Matic. That is not fun. File. Anyway, I'll fix it later. But I'm definitely not happy about the number of significant digits there. Data. Ah, there we go. Ugh. This is not behaving as I like. And then I'm going to do standard deviation equals ST. And from the first lab and the second lab, just the regular standard deviation. What do you want me to do? Yeah, usually when you're doing this, you have different tools available, and it tries to autofill. So Screencast-O-Matic is not my friend this morning. Enter. Boom. Ugh, that looks big. Standard deviation. Why is it so large? That doesn't seem... C6 to C39. I mean, just looking at that, something's not quite right. Well, again, I'm not overly concerned. What I am concerned about is that average. All right, so now I'm going to come over to this side and I'm going to create a little box for myself for a working area. And so now I have V theory, right? V sub t, and I don't mix math and words together. So V theory is, right, root 2GH. We did that on the board. You have it in some of your supplemental materials. You might have picked that up if you've been paying attention in class. So how do I get that to do it? Equals SQRT. Now you know the square root command for Excel. Square root of 2 star times G, which is 9.81 in this case. You could use more significant digits if you look it up. This is fine. And the height of the drop is right here, right? How high did I drop it from? 0.67 meters. I don't need to put the O. Close parentheses. Enter. Boom. There is my theoretical velocity. I go down here and I look and I go, oh, my average velocity was pretty close. All right. How close? This is the meat and potatoes of this whole lab. Relative error, right? Right. How do I find the relative error? You know what? I'm going to make this column bigger just to make it look a little nicer. I wish I could make it colored, but I'll live. What is the relative error? Well, it is going to be, again, Excel, do math for me, equals, open parenthesis, my actual value, which is sitting right here, right? So I just click it. It's C41, right? Minus the theoretical value, the value in G7, close parentheses, right? PEMDAS, divided by G7 again, right? And then times 100. 6% relative error. Nice. All right. Let's... Well, I'll have to figure out how to do that in Screencast-O-Matic. That's a tutorial for teachers on another day. But the threshold was 20%. 6% is very small. Oh, it's positive. Seems a little fast. That indicates that I might have gained a little energy. But I'm in a high school science lab. You know, if it's plus or minus a little bit, I'm good. If I'm under 10%, great. In this lab, 20% was my threshold. Energy was conserved. I just go here, energy was conserved. Do I have to do anything else? No. I am done. I've done 1/3 of your lab for you. You're welcome. And have a great rest of your day.